In October 30 on, Atlas drifts near the Sun, hidden behind its glare, a superior conjunction when Earth, the Sun, and the object fall into perfect line. The last images came weeks ago. Since then, nothing. ESA's instruments are quiet. NASA remains dark. The silence feels deliberate. Every time a body crosses behind the Sun, something ancient happens. The meeting of radiance and shadow, the folding of observation itself. We call it a superior conjunction, but in truth it's a moment of disappearance, a test of how well we can see when the light blinds us. What if this silence isn't absence at all, but data in another form, a signal written in radiation and distance? What happens when a visitor from interstellar space vanishes behind our own star, and the only thing left is the hum of light itself? And that's where our journey begins, in the quiet shadow of the Sun, where 3i Atlas hides. The object has slipped behind the Sun. For days, telescopes have gone silent, no signal, no reflection, no trace on the solar monitors. Only a faint curve remains on our data screens, the last echo of 3i Atlas before it vanished into the blinding heart of light. We stand on the dark side of Earth, beneath the long shadow of our own planet, watching the Sun from a distance of 1 astronomical unit, 149 million kilometers. If you were to draw a line from here to that star, the object would now be hidden exactly behind it, less than 2 solar diameters away from perfect alignment. To us it is gone, yet we know it's there, moving at 68 kilometers per second, fast enough to circle the Earth in 10 minutes. Close your eyes. Imagine you could stand at the edge of that alignment where sunlight folds into radiation storms. The brightness would be unbearable. Every square meter around you would receive 700 watts of energy, like 7 lamps burning on a single tile. Space. There is not black, it glows white and gold, alive with charged particles. The airless silence vibrates. Scientists call this phase superior conjunction, when a celestial traveler passes directly behind the Sun from Earth's point of view. It happens to every inner planet, but rarely to an interstellar visitor. Instruments must wait. Cameras cannot stare into a furnace. For a week, all data becomes blind. We can only model the trajectory, tracing the invisible through numbers. If we could see through the Sun's glare, 3 Atlas would appear as a faint speck wrapped in vapor. Its coma-thin gas and dust, evaporating under radiation, would stretch for thousands of kilometers, larger than Mount Everest by 100-fold, nearly the width of a small country. That cloud would shimmer, scattering photons like sparks over a cosmic anvil. And yet silence is data too. Astronomers note the absence, charting how long the object stays hidden, comparing it to patterns of previous visitors, Oumuamua in 2017, Borisov in 2019. Each had its own period of disappearance, its own encounter with the Sun's domain. 3i Atlas follows, but deeper into the light, closer to the furnace than either before. For those watching the sky, this moment feels like a held breath. A visitor from beyond the stars, swallowed by our nearest star. The Sun, radiant and relentless, becomes both veil and stage. We can't see through it, but we can sense the story continuing behind that wall of plasma. Perhaps that is how knowledge often moves, vanishing behind brilliance, forcing us to look not at what is visible, but what persists in the unseen. The data feed remains blank. The world turns beneath the same sky. Somewhere beyond that brightness, an object older than the solar system drifts through light, dense enough to melt stone, tracing a curve that no one can witness, yet all of science can feel. For 7 days, the Sun has been too bright to look at. Every instrument that once tracked 3i Atlas now stares into white noise. The solar wind drowns all frequencies. The detectors return streams of static. NASA's heliophysics monitors the ESA solar orbiter. Even amateur observatories from Chile to Hawaii all report the same result, a clean, featureless wall of energy. We are for a brief moment blind, yet blindness has its own clarity. Stand with me here on the midnight side of Earth. The planet's shadow stretches behind us like a cloak. Above the horizon, the Sun is hidden, but its influence fills every atom. If you could hold your hand to the darkness, it would still glow with scattered photons. That is how vast the light is, how impossible it is to truly escape it. At 1 astronomical unit, sunlight arrives as a pressure of 4.5 micronewtons per square meter, soft but relentless. At 36 AU, where 3i Atlas now passes, that pressure is weaker, yet still enough to nudge dust grains and bend tails of plasma. Imagine wind made of light, each photon a bullet that never misses. The object moves through that invisible storm, its coma trailing behind like the wake of a ship through golden mist. If you could see it, if your eyes were resistant to radiation 1,000 times stronger than daylight, you would witness a delicate geometry. The sun in front, the object behind Earth offset slightly to the side. Lines of electromagnetic flux connect all three, forming a triangle in the void. It's not just a position in space, it's a relationship. Energy flows between them like tides. The phenomenon has a name, superior conjunction geometry, but to stand inside it would feel almost spiritual. Here, physics and awe overlap. A beam of light leaves the sun, grazes the surface of the object, and continues toward the outer dark. Each photon that touches it is older than you, born from fusion reactions that began 10,000 years before the light reached the surface of the sun itself. When it strikes 3i Atlas, it is meeting something even older, matter forged before the sun existed. A collision between epochs. We can't see it, but we can calculate. The last confirmed coordinates place 3i Atlas near right ascension, 13-ish Twintum declination, 9G moving southeast across the ecliptic at roughly 68 km/s. If you imagine tracing that path on a map of the solar system, it's crossing a distance equal to 3 times the orbit of Mercury every month. Faster than any comet we've seen, too fast to be bound by gravity. Astronomers use predictive modeling now. They feed equations into orbital mechanics software, Kepler's laws, perturbation matrices, solar radiation pressure terms, to guess where it will emerge once it clears the sun's glare. But numbers can't fill the silence completely. Between one observation and the next, there is a gulf, a gap that even data fears to cross, and so we wait. In that waiting, you begin to notice something human. We are a species addicted to sight, terrified of blindness. Yet in astronomy, every discovery begins with what we cannot see. The edge of the observable universe, the dark matter between galaxies, the hidden cores of black holes, all are born from absence. Maybe this week of blindness is not a loss, but an initiation. Close your eyes. Picture yourself near the sun's rim, your visor filtering waves of gamma light. Ahead, a curtain of radiation burns white, pulsing with magnetic arcs taller than Earth itself. Behind that curtain, unseen, a visitor moves uncharted, uninvited, yet precisely on course. The sun roars, but it also hides. That hiding is part of the pattern. When Oumuamua passed in 2017, it too disappeared, briefly swallowed by glare. When Borisov crossed in 2019, the same silence fell. Each time we turned away from the star and toward our instruments, waiting for the first pixel to return. Each time the reappearance felt like revelation. The cosmos teaches by erasure. It blinds us until we learn to see differently. Soon the sun will rotate, the geometry will shift, and 3 Atlas will emerge again, faint, perhaps fragmented, perhaps transformed. Until then, our eyes remain closed, but our equations stay awake. Every second, the models run, integrating new solar data, recalculating perihelion distance, refining predictions. The next detection could appear anywhere along that curved arc of probability, a ghost of light against the sun's fading corona. The graphs have stopped moving. Telemetry streams that once danced with numbers now rest as flat lines. No flares, no dips, just stillness. To some, that means nothing is happening. To others, it means everything is. Across the world, observatories turn their antennas toward the sun's hidden side. Datasets from NASA's Parker Solar Probe, the European Space Agency's Solar Orbiter, and Japan's Hinode mission all converge on a single region, a thin slice of sky behind the solar limb where 3i Atlas should be passing. But the data is motionless, wrapped in silence. At first, scientists suspect interference. Solar storms can overload sensors, magnetic surges can skew readings, and cosmic rays can mimic signal loss. But this stillness is too clean. It's not chaos, it's absence. A perfect calm within a storm of radiation. From the surface of Earth, the sun looks serene. Yet beneath that calm, its corona rages at 1,000,000 degrees Celsius. Filaments of plasma twist like serpents, carrying magnetic fields 100 times stronger than any human generator. Every few minutes, a flare erupts, releasing energy equal to billions of nuclear bombs. Still, our instruments hear nothing. Let's stand here for a moment in the quiet between bursts. If you could drift just above the solar corona, you would see a pale ocean of plasma shimmering like silk. You would also notice the darkness that isn't darkness at all regions, where light bends, scattering particles until they vanish from view. Somewhere in that glare, smaller than a city, 3i Atlas, moves its body absorbing heat, reflecting only a whisper of light back to us. To find such whispers, astronomers filter raw data pixel by pixel. They remove solar noise, subtract background radiation, and stack exposures. Each operation sharpens the possible trace of a traveler that may never appear. The process is less like photography and more like archaeology, dusting layers of brightness to find a single ancient mark. Imagine holding an image so overexposed that only white remains. Now imagine that hidden in that white lies the shadow of something that came from beyond the stars. That's what the researchers search for, evidence folded inside light itself. During conjunction, 3I Atlas receives energy like no other moment in its lifetime. At 136 astronomical units from the Sun, it absorbs roughly 735 watts per square meter energy, enough to boil steel if sustained. Its surface likely composed of frozen volatiles, methane, CH4 carbon dioxide, CO2 water ice. H2O must be erupting, releasing plumes of gas that expand for hundreds of kilometers. Each molecule escaping into sunlight tells a story: where it was formed, how long it has traveled, what stars it has passed before finding ours. Data from previous interstellar objects offer a scale for comparison. Oumuamua reflected light irregularly. Its brightness changed eightfold, with each rotation suggesting an elongated tumbling shape, roughly 200 by 30 meters. Borisov, by contrast, was stable, spherical, glowing with cyan from ionized carbon. If Thracios Atlas behaves differently, its signature will stand out once it re-emerges. Until then, models simulate what we cannot see. Mathematicians run Monte Carlo predictions, 10,000 possible orbits, 10,000 ways the object might curve out from behind the Sun. In most it survives. In some it fragments its dust, spreading like a faint exhalation into interplanetary space. In all cases, its speed 68 km remains unbound. Gravity cannot keep it. There is beauty in this uncertainty. For centuries, astronomy has been about patience, learning to read what the universe writes slowly. Light from distant galaxies takes billions of years to reach us. A single missing signal may still be traveling unseen across that ocean of time. Perhaps the data isn't absent, it's simply late. Close your eyes. Picture a blank screen in a control room. Engineers sip cold coffee, eyes fixed on the flat line. Outside, dawn begins to brighten. Somewhere above the Sun, particles rush at near light speed, striking magnetic fields and scattering photons like dust in a storm. Every computer hums, recording emptiness. Yet in that emptiness, anticipation hums louder. Soon, a spike will appear 1 point above the baseline, 1 pixel that breaks the calm. That will be enough to prove it's still there. Stillness is not death. Stillness is the breath the universe takes before exhaling discovery. Perhaps this is what science has always been, listening to silence until it speaks. The moment will come when the flare subsides, when detectors open their eyes again, and the first new data trickles through the noise. The silence breaks not with sound, but with heat. From the stillness of the data we move closer, into the fire itself. The numbers that once rested flat now climb, tracing the slow heartbeat of the Sun. 3 Atlas is no longer hidden. It is entering the region of maximum illumination, where radiation becomes architecture and light itself has weight. We have crossed from absence into intensity. Imagine you are standing at the edge of the corona 2 million kilometers above the solar surface. The Sun below isn't a disk, but a living storm, filaments of plasma curling in magnetic loops, each tens of thousands of kilometers high, higher than 10 Earths stacked together. The temperature here is 1 million degrees Celsius. Space doesn't glow, it screams. At 1.36 astronomical units, about 203 million kilometers, the object now receives 735 watts of energy for every square meter of its surface. That's 7 bright bulbs burning on every tile of a ship thousands of meters wide. No atmosphere to cool it, no wind to carry the heat away. Only radiation, direct and merciless. The coma around 3 Atlas expands in response gas boiling from frozen ices, spraying in jets that twist into spirals under the Sun's electromagnetic grip. Each plume extends for hundreds of kilometers, luminous like the aurora, but denser, heavier. The nucleus at the center, maybe 5 kilometers across, glows faintly blue from carbon monoxide and cyanide molecules breaking apart. It is chemistry under siege, physics at the threshold of survival. The Sun dominates everything here. Even at this distance, its gravity holds the entire solar system in orbit. Its magnetic field stretches beyond Pluto, Its radiation fills a sphere 90 billion kilometers wide, the heliosphere. 3i Atlas moves through that sphere like a small seed through a furnace, its trajectory unbound, its destiny unknown. If you were close enough to watch it, the scene would look unreal. The sun would appear 3 times larger than from Earth, its surface rippling like molten glass. Solar prominences, arches of fire taller than planets, would burst outward, collapsing back in slow motion. Every few minutes, charged particles would slam into your shield, each with energy measured in mega-electron volts. Hold that image for a moment. The light pressing on your visor, the heat moving through your suit like invisible wind. You would see the object ahead dark against the radiance, trailing a long ribbon of vapor. A comet, yes, but not a native one. Its motion too clean, its acceleration too smooth. It doesn't behave like debris, it behaves like intention. Back on Earth, observatories detect faint variations in solar X-ray flux ripples, synchronized with the object's predicted position. Whether it's coincidence or consequence, no one can say. The data flickers, the algorithms argue, the sun keeps burning. Every star is a question, and every visitor a possible answer. If 3i Atlas is natural, it carries the physics of another sun, perhaps a relic expelled when that system was young. If artificial, it might be the first message ever delivered by motion itself, a geometry written in orbit and temperature instead of code. Speculation is dangerous here, so is silence. Scientists stay grounded in thermodynamics, emissivity, coefficients, sublimation rates. But under those numbers hides something ancient, the feeling that light is alive. You sense it too, don't you? Standing here in imagination with the furnace around us, every nerve becomes an antenna. We are no longer observing, we are participating. The photons that strike 3i Atlas are the same that strike your skin, delayed by only 8 minutes. You are connected to this object by the very light that burns it. Soon it will swing around the sun and head back into the dark. But in this instant it exists in balance between destruction and revelation, between the certainty of heat and the mystery of purpose. From the furnace we just entered, everything begins to thin. Light still burns, but it starts to obey its oldest law, the law of fading. When a beam leaves the surface of the sun, it expands through space like a growing sphere. Its power stretches, dilutes, becomes softer with every kilometer. Physicists call it the inverse square law. The intensity of light decreases with the square of the distance. Double the distance and the brightness falls to 1/4. Triple it and only 1/9 remains. It's a simple law, beautifully cruel. The farther something drifts from the source, the colder it becomes. If you stand here with me, 150 million kilometers from the sun, your skin receives about 1,360 watts per square meter, the warmth of daylight that sustains every leaf, every breath. But step outward to 3i Atlas, 1.36 astronomical units away, and the value drops to 735 watts. A number precise enough to be poetry. That is how the universe measures distance, not in kilometers, but in the loss of light. Imagine holding a match in a cathedral the size of space. Each step you take away makes it smaller, weaker, until flame and darkness are indistinguishable. That's the geometry of everything we see, the fading of energy into silence. And yet, paradoxically, this law of loss is what allows us to know the cosmos at all. By how much the light dims, we measure distance. By the time it takes to fade, we learn the age of stars. Even in its vanishing, light tells the truth. The same principle rules the fate of 3i Atlas. As it nears perihelion, its closest point to the sun, it swims through rising brilliance. But for every meter it travels outward again, the pressure of radiation will weaken exponentially. What now feels like a storm of photons will soon turn to drizzle. The coma will collapse, the tail will shorten, the luminous breath will fade into invisibility. The object itself obeys a kind of physics of memory. Heat penetrates, vapor erupts, surface fractures form, but when the radiance declines, everything freezes again like molten glass solidifying in air. The pattern is ancient creation through destruction, cooling through distance. On Earth, the same principle holds in every sunrise. Each dawn begins with saturation colors too bright to look at. But as the sun climbs, scattering, spreads, intensity softens and light becomes livable. The inverse square law is what saves us from burning. In mathematics, the rule is simple, though it feels almost poetic. Light spreads out as it travels and its power softens with distance. If you move twice as far from the source, the brightness becomes 4 times weaker. Move 3 times farther and it fades to just 1/9 of what it was. The sun pours out about 3.8 followed by 26 zeros watts of energy every second. By the time that light reaches Earth, 1 square meter receives about 1,360 watts, the warmth that sustains our days. But at the orbit of 3i Atlas, farther from the sun, the same square meter feels only about 735 watts. That gentle loss of light is how the universe keeps balance. Every meter outward cools the flame. It isn't merely a number or a formula, it's the rhythm of existence itself. Now look at the sun again. You can't not directly but imagine it behind your closed eyelids. Feel how its brightness presses through even the skin of your hands. The photons hitting you now left the solar surface 8 minutes and 20 seconds ago. In that time, 3i Atlas has traveled more than 32,000 kilometers, cutting through the golden current like a needle through silk. The sun gives, space takes. That balance is everything. Perhaps this is why ancient cultures worship the sun as both god and destroyer. It offers life, but it also erases sight. It reveals the world, yet blinds those who stare too long. In that duality, they sensed a truth physics later confirmed: energy defines the limits of knowing. Too little and nothing exists. Too much and nothing can be seen. Scientists watching the conjunction note the same irony. The closer 3i Atlas moves to the source of knowledge, the more invisible it becomes. The data turns to whiteout numbers, saturate sensors max out. It's as though the sun guards its secrets with brightness instead of shadow. You can feel that principle everywhere, in human thought, in memory, in discovery itself. Approach any idea too closely and it dissolves into glare. Step back and shape returns. Every truth has a distance at which it can be seen. If you could drift beside the object now, you would see it glowing faintly in the half shadow of its own dust. Jets of vapor burst from fissures, freezing mid-flight, turning to snow that falls into vacuum. The surface, once dark, now mirrors the sun's fury, polished by sublimation, until it shines like obsidian. For every second, the law of inverse light shapes it, pushing gently, bending its path, writing invisible pressure into its orbit. Over millions of kilometers, these tiny forces accumulate, shifting the future trajectory by degrees that could mean entire planets' widths. That's how light sculpts the universe quietly, relentlessly. We are made of the same obedience. Our bodies live by the measured grace of distance. Our minds thrive in the equilibrium between brightness and shadow. Soon, 3 Atlas will reach the peak of illumination, then begin to fall away. Its surface will cool, its brightness will decay, according to that perfect equation. But in every watt it loses, we gain something else: understanding. The sun has grown louder than our instruments can bear. Every wavelength screams, every field saturates until the entire sky collapses into a single, blinding tone of white. And then the tone disappears. That is the paradox of power. When everything reaches its peak, it sounds like nothing at all. The data returns to stillness not because activity has stopped, but because energy has exceeded our ability to measure it. This is what astronomers call the supercharged silence, the moment when the star's radiance overwhelms observation itself. It is not quiet out there. It is a choir too vast for our ears. Imagine being there, floating only a few solar radii above the surface of the sun. Around you, arcs of plasma rise like cathedral columns of fire. Each loop towers higher than 10 Earths stacked together 100,000 kilometers from base to crest. They move in slow motion, bending under the invisible hand of magnetism. The temperature here exceeds 1 million degrees Celsius, yet space remains almost empty, thinner than any vacuum we can build. A paradox of fury and absence. Now picture 3i Atlas cutting through that brightness. The object is no longer cold and dark, it is alive with reaction. Its nucleus, roughly 5 kilometers wide, boils as sunlight hammers its surface. Frozen ices, water, carbon dioxide, methane sublimate directly into vapor-forming jets that twist outward like luminous threads. Each jet travels for thousands of kilometers before dispersing. Together they create a tail longer than Earth's diameter, glowing faint blue against the sun's gold. But around this fury there is no sound. The violence is total yet mute. 1 billion hydrogen atoms slam into every square centimeter each second, and not a single one makes a whisper. Silence born from excess. Let's pause here in the eye of that impossible storm. At this distance, the solar wind blows faster than 400 kilometers per second, enough to travel from New York to Tokyo in 10 seconds. Each particle carries an electrical charge, a fragment of the sun's skin. When they strike the object, they peel away electrons, leaving behind ions that shimmer like dust made of light. If you could see through ultraviolet eyes, 3I Atlas would gleam with a ghostly corona of its own, a halo of charged gas shimmering in blue-white arcs. Radiation pressure presses against its surface, subtle yet relentless. On every square meter, sunlight pushes with a force of just a few micronewtons, barely enough to move a feather. But when applied over the entire body of the object, that feather force becomes monumental. Over months, it can alter the path of an interstellar traveler by thousands of kilometers. This is how light sculpts trajectories, not with violence, but with persistence. Astronomers run simulations, plotting the drag of light, the gravity of the sun, the jets of gas, and they find something uncanny. The motion of 3I Atlas remains smoother than expected. No erratic spin, no chaotic wobble. Almost deliberate. It's as if the object adjusts to the storm instead of being consumed by it. Could that be coincidence, perhaps? Or perhaps its structure is unique porous rock bound by magnetic minerals, creating natural stability. Or maybe, as some quietly speculate, it is built, not born, an artifact of physics so ancient it has forgotten its makers. Below the blazing arcs, the sun continues its endless heartbeat. Solar flares erupt every few minutes, releasing energy equal to billions of atomic bombs. Each one launches a wave of X-rays across space, a pulse that instruments on Earth will detect about 8 minutes later. For a brief instant, the whole electromagnetic spectrum vibrates like a struck bell. During these pulses, data from the Parker Solar Probe shows small dips and fluctuations, echoes, that align eerily with the projected path of 3I Atlas. Coincidence again, perhaps. But the timing repeats, and repetition in science is where curiosity begins. The team at NASA's heliophysics division filters the data again. The pattern remains faint, rhythmic, as though the object itself were modulating the storm. Could light interact with matter to such precision, shaping a signature inside the chaos? Or is the sun simply mirroring our wish to find meaning? Even silence can echo if you listen long enough. Let's step back from the instruments and imagine the scene directly. The sun fills half the sky. Everywhere you look, waves of plasma ripple in slow, graceful motion. The light is so intense that your shadow disappears. It is cast in all directions at once. Ahead, the small dark seed of 3I Atlas drifts through that ocean, leaving a wake of luminescent dust. Particles scatter behind it like embers in a cosmic wind. They will continue traveling long after the object itself has gone, carrying its trace through the solar system, a faint cometary fingerprint of interstellar origin. At this point, even our most sensitive instruments can no longer follow. The noise is too high, the flux too strong. Every sensor maxes out, every detector blinds itself for protection. So humanity does the only thing left to do: we wait and we watch the sun itself. Its face becomes a screen. Its flares the only communication we can read. We turn blindness into observation by accepting the limits of seeing. It is strange, this relationship between knowledge and silence. The more we learn, the closer we get to the point where knowing dissolves. A physicist once said the universe is not silent because nothing happens. It is silent because everything happens at once. In the supercharged silence, that statement becomes literal. All frequencies collide, every note overlaps until the orchestra of light folds into a single inaudible chord. Somewhere inside that chord, 3I Atlas continues to move. Unseen, unmeasured, perhaps already altered by its brush with the solar furnace. When it emerges again, it may look different. Darker, lighter, fractured or reborn. Whatever it becomes will carry the signature of this moment. On Earth, evening arrives. The sun sinks below the horizon, and for the first time in a week, the observatories rest. The hum of the data servers quiets, fans, slow screens dim, and in that stillness you can almost feel what the object must feel, that brief suspended heartbeat between the fury of creation and the coolness of the void. Because silence is not the absence of energy. It is the form energy takes when it has filled every possible space. It is the exhale after light has spoken its first and last word. Soon the brightness will begin to fade. The temperature will drop, the tail will narrow, and the object will slip away from the sun's gravity. But before it does, the star will leave its mark, a brand of light, etched into whatever this traveler truly is. And as it drifts outward back toward the chill between the planets, the solar wind will carry whispers of that encounter across the system. Each atom of gas, each dust grain glowing for a heartbeat, before falling dark again, will be a messenger, a reminder that even the loudest star speaks most clearly in its quietest moments. The storm is passing now. The sun exhales, light softens. Three-Eye Atlas begins its long retreat from the furnace. The storm is passing now. The sun exhales, light softens. We are moving outwards, slowly, steadily away from the furnace that once drowned every signal in fire. Three-Eye Atlas drifts through the waning glow, its long tail thinning into ribbons of vapor folding back toward darkness. The solar wind weakens, radiation quiets. In this silence, the universe begins to cool. We have left behind the soundless roar of the sun. What remains is the faint hiss of the solar wind fading through distance, like the ocean heard from miles away. At 136 astronomical units, sunlight still presses faintly on the object's surface, 700 watts per square meter, a gentle breath compared to the inferno it endured at perihelion. Every minute of travel stretches that light thinner. By the time it reaches twice this distance, only a quarter remains. The law of fading light governs all things comets, planets, and memory alike. Imagine you're floating here beside it, where day and night have no meaning. Ahead lies a sea of black glass scattered with small grains of light. Mercury, Venus, Earth, Mars, each a slow spark in the endless tide. The sun behind you has shrunk to a bright coin. Its heat feels like an afterthought. Between you and the next star lies emptiness so pure that even silence seems too loud. This is what cooling feels like in the language of space. The plasma that once wrapped around the object now begins to contract. Ionized gases recombine into neutral atoms, their colors fading from electric blue to soft gray. The coma shrinks, forming a shell of frost. Dust grains settle into an orbiting halo, each the size of a grain of sand yet shining for a heartbeat before freezing completely. The Parker Solar Probe confirms the change. The solar wind density has dropped by half the temperature by a third. The sun's electromagnetic pull lessens, allowing the object's true trajectory to unfold an arc leading away from the inner system, perhaps out toward Jupiter's orbit before it slips once more into the deep dark between the stars. Here, temperature is not measured in warmth but in motion. In the void, what we call cold is simply the absence of vibration. At this distance, space itself holds a temperature of about -270 degrees Celsius, 3 degrees above absolute zero. Every atom vibrates only faintly, conserving its last memory of heat. Three-Eye Atlas carries that memory too. Its crust still glows faintly in infrared, a heat signature, recorded by the James Webb Space Telescope. That glow will fade within weeks, but for now it's a scar of survival, the trace of what the sun has written upon it. In science, we call it residual thermal emission. In human language, it is the echo of endurance. Think of it like walking away from a bonfire on a winter night. The flames grow smaller behind you, but your skin still carries their warmth for a while. That warmth fades, but you remember it. So does the object. The sun has branded it with memory. Now, the space around us grows darker, thicker, slower. Radiation falls silent. Only the cosmic background remains, the faint glow left from the birth of the universe, the whisper of the Big Bang stretched across eternity. It hums at a temperature just above nothing. That hum is everywhere in your radio, in the static between stations, in the background of thought itself. The object is entering that hum now, a realm where everything that once burned is remembered only by its faint vibration. We are following it into the quiet. The vast heliosphere, the bubble of solar influence, extends for nearly 100 billion kilometers. Inside it, the sun rules. Beyond it, interstellar space begins a domain of drifting atoms and magnetic shadows. Three-Eye Atlas moves toward that threshold, leaving the known warmth of our system for the unlit plains beyond. Its speed, 68 kilometers per second, has barely changed. Fast enough to circle Earth in 10 minutes, fast enough to escape the sun forever. Yet from here it looks motionless, suspended between the light it has left and the dark it has yet to enter. Silence takes on new meaning here. It is no longer absence but equilibrium. Every particle, every photon, every trace of movement balances perfectly against the void. You can almost feel time itself slowing, not as an illusion but as physics. We stand beside it in thought, two travelers, one human, one interstellar, both cooling in the same expanding breath of space. You realize something profound in this cold. The absence of warmth is not emptiness. it is potential. Cold is where light rests, where heat becomes memory, where motion pauses long enough for reflection to exist. The astronomers on Earth will soon detect the object again. Their instruments will note the drop in brightness, the tightening of the tail, the spectral shift from blue to amber as the gases freeze. To them, this is data. To us, it feels like listening to the aftersound of a bell long after it has stopped ringing. The sun has stopped shouting. Now the universe is whispering again. And in that whisper lives an understanding that every journey away from fire is not an end, but a deepening. 3 Atlas is not dying. It is remembering what it was before light found it, and as it glides outward, it carries the sun within not as flame, but as a trace of radiance folded into silence. The cold has deepened, the fire is gone, and only its memory hums beneath the crust of 3I Atlas. It should be silent now, frozen asleep, drifting through the dark between orbits. But something is stirring. Not motion, not noise, a kind of awakening. After leaving the furnace, the object is supposed to enter dormancy. The sunlight fades, the gases freeze, the tail collapses into dust. For all measurable purposes, it becomes inert. Yet as the observatories begin tracking again, the Very Large Telescope in Chile, the Subaru Observatory in Hawaii, the Webb Telescope beyond the Moon, something unexpected appears in the returning data. The brightness does not decline as predicted. In fact, it fluctuates. A slow pulse, faint, periodic, as though the object were breathing. Every 2.5 hours, the reflectivity changes by a small but measurable fraction. Not random, not chaotic, rhythmic. It is as if the light curves have learned to speak. On Earth, the first model suggests simple rotation. Many comets tumble as they move, changing the amount of light they reflect. But this is different. The frequency remains constant even as the orientation shifts. No known mechanical motion fits the pattern cleanly. Imagine standing far behind the sun, watching the object from a distance of 200 million kilometers. The light you see is already 12 minutes old, stretched thin by the void. Each flicker you observe is a delayed echo, a heartbeat from a traveler made of ice and dust. It shouldn't be alive, yet the rhythm feels deliberate. Astronomers start comparing the sequence with previous interstellar objects. Oumuamua in 2017 showed a chaotic spin, 3 rotations intertwined, each with irregular brightness. Borisov 2 years later spun gently, more like a normal comet. 3Os Atlas behaves like neither. Its light curve follows a pattern closer to a harmonic oscillator than to a rock tumbling through space. The amplitude, the height of each pulse increases and fades in cycles, as though the object is responding to something external. Radiation pressure, magnetic resonance. No one knows yet, but for those who study these signals late into the night, it feels strangely intimate, as though the void itself were breathing through the data. The sun now lies far behind us, a pale sphere framed by black. The temperature of space here is near -270 degrees Celsius, only a few degrees above absolute zero. At such extremes, molecules barely move, and yet deep inside, the object heat still lingers, trapped in rock and metal. Thermal inertia, the slowest kind of heartbeat in nature. You can picture it: layers of ice, cracking gases shifting beneath the crust, pressure building, then easing like sighs under stone. Each microfracture releases a wisp of vapor, a thin exhalation invisible from afar but strong enough to push against the void. To the telescope, that exhalation becomes a faint pulse of light. Science explains it simply: sublimation cycles, surface fractures, delayed heat conduction. But standing here in imagination, it feels alive. Not in the biological sense, but in the cosmic one matter adjusting to memory. The Webb telescope captures new spectra. Instead of a pure reflection curve, it finds traces of something else weak, emissions near the wavelengths of cyanogen and carbon monoxide modulating in intensity. It means the surface isn't just cooling, it's reacting. Atoms that slept for millions of years are stirring again, awakened by their passage through the sun's fire. We could call it thermal recovery, but another word fits better: recollection. The object remembers. Light travels outward, but heat lingers, echoing within its core like music trapped in stone. In every pulse, you can sense the story of its creation, the collapse of an ancient star, the condensation of dust, the birth of a system long vanished. This object has survived epochs. It has crossed the darkness between suns, and now, after bathing in our star's fire, it carries a new layer of history on its skin. You and I stand together in thought, drifting beside it. There's no sound here, no horizon, only the quiet geometry of movement. In this region, gravity loosens its grip. Even time begins to feel stretched, minutes become longer, seconds more patient. When you look back, the sun is small enough to hide behind your thumb. Ahead, the stars form an ocean. The temperature stabilizes. The radiation pressure fades to near zero. This is where stillness stops being silence, it becomes awareness. Think of it as a universal law. After every great burning, something wakes. Not violently, not suddenly, but with grace. The cosmos never sleeps completely. It breathes between its own extremes. What we're witnessing now, this faint rhythmic flicker, may simply be the mechanical settling of material. Or it could be something subtler, an emergent rhythm, a conversation between matter and radiation, heat and cold. No one can yet tell whether it is cause or coincidence, reaction or reply. But the data doesn't lie. The pulse remains. Every 2.5 hours, the light climbs peaks and falls, not unlike a heartbeat, not unlike the breath of a sleeping creature sensing dawn. From Earth, the reports spread. Scientists exchange hypotheses, poets write metaphors, dreamers stay up late watching real-time plots of light intensity. The community begins to call it the awakening curve. It becomes a quiet symbol, the idea that even in the coldest space, motion persists. Perhaps this is the cosmos teaching its oldest lesson, that awakening does not always mean noise or brightness. Sometimes it is just the continuation of rhythm after chaos, the faint persistence of being. 3 Atlas continues outward, now past the orbit of Mars, heading toward the belt, where Jupiter's gravity hums. Its journey will last months before it leaves our heliosphere. Long after it disappears again, its pulse may continue unseen, unheard, but not unmeasured. And so we listen. Through equations, through silence, through the shimmer of faint data. We listen not because we expect an answer, but because listening is what keeps us awake. The sun behind us fades to memory. Ahead lies distance wide, dark infinite, and so the traveller moves on. The light has grown small behind us now. The sun, once a living storm, is nothing more than a golden ember half swallowed by the Black Sea. And 3 Atlas drifts through the dim corridors between planets, carrying the faint warmth of everything it has survived. For weeks, astronomers have been gathering data. Spectralite curves, gravitational vectors, the language of observation. Each number tells a part of the story, yet none capture what the object truly is, a relic that remembers. The heat it gathered near the sun has not vanished. It lingers deep within its layers, trapped like the glow beneath cooling metal. Every rotation, every subtle crack of the crust releases a whisper of that stored energy back into the dark. Infrared telescopes detect it as a faint shimmer, a ghost of warmth. The signal fades slowly, logarithmically, but it never reaches zero. In physics, this is called radiative decay. In poetry, it is called memory. Imagine holding a stone that was once inside a fire. Even after hours in the open air, it stays warm to the touch, as if it refuses to forget the flame. Now extend that feeling to a traveller the size of a mountain gliding through billions of kilometers of frozen space. It carries not just heat, but experience, a record of collisions, of light, of time itself. Scientists compare this persistence to the behavior of other interstellar visitors. Oumuamua, when it passed in 2017, reflected sunlight with strange irregularity. Some thought it was tumbling, others believed it was thin, perhaps shaped like a sail. Its brightness fluctuated unpredictably, a geometry of chaos. 2 years later, Borisov followed, colder and rounder, releasing gases in familiar cometary fashion. It was the comfort of the known. But 3 Atlas is different. Its structure, density, and response to sunlight all defy the categories we built. Its albedo, the fraction of light it reflects, changes too precisely, too rhythmically, as though tuned. When scientists plot its data against time, the result forms a pattern not random but harmonic. Peaks and troughs small and symmetrical, echoing in intervals that mirror the timing of solar pulses from weeks before. A resonance between a star and its visitor. Could light leave an imprint not just on surface temperature but on behavior itself? Could radiation teach matter a rhythm? If so, the memory of stars may not be metaphor at all, it may be literal. Picture this. You're standing on the hull of an invisible ship moving through darkness. The sun is a distant spark behind you. Ahead, the stars multiply into a river of scattered light. Each one hums faintly in its own frequency, each one a heartbeat in the vast organism of the galaxy. In that chorus, 3 Atlas drifts one small note, carrying the timbre of the star it passed. It doesn't sing loudly. It resonates quietly, folding the solar pulse into its own rotation. Astronomers at ESA begin to notice the pattern extends beyond visible light. Infrared sensors pick up modulation in thermal emissions, pulses separated by hours, sometimes days. When analysed, they align with solar wave patterns recorded weeks earlier by the Parker probe. Coincidence, maybe, but the repetition is unnerving in its precision. The data behaves like an echo that refuses to fade. Every time the sun vibrated, the object responded, and now, even in the cold, it keeps the rhythm alive, a distant glowing metronome in the void. One scientist describes it like this: "It's as if the sun taught it a song before letting it go." This is not the first time the universe has shown such persistence. In dying stars, light carries memories of fusion that ended billions of years ago. In cosmic background radiation, we still hear the faint hiss of creation itself, photons older than galaxies. Every particle of matter, in a sense, remembers the heat of its birth. And perhaps these travelers, Oumuamua, Borisov, Atlas, are vessels of that remembrance. Each crosses our system, once briefly leaving a signature we struggle to decode. They do not speak in signals, but in physics, light curves, spectra, magnetism, and silence. And we curious species of Earth try to read those silences as language. What if they are? What if the memory of stars is how the universe keeps speaking to itself? Each fragment of matter, each beam of radiation is a form of correspondence not between minds, but between moments. When we detect it, we're simply intercepting a conversation already billions of years old. 3I Atlas continues outward now near the orbit of Jupiter. At this distance, sunlight has weakened to 1/25 of its strength on Earth. The object no longer glows in visible light, only in infrared. To human eyes, it would appear as a shadow darker than the surrounding night. But instruments see differently. The European Space Agency's tracking network records the faint heat trail, a line of warmth across emptiness. Each pulse matches the same rhythm discovered earlier, though fainter, now stretched by distance. The pulse persists stubborn against the cold. It is a fragile miracle of measurement, the warmth of a mountain carried through the void, repeating a pattern written by a star. If you could hold your breath long enough, you might hear it not as sound but as presence, a feeling that somewhere out there matter still remembers light. And what about us? Every atom in your body was once inside a star hydrogen forged into carbon, oxygen, iron. We are quite literally stardust remembering itself. Our warmth is borrowed from fusion. Our consciousness is an echo of energy that once burned in the cores of suns. Perhaps that is why we feel such quiet recognition when we watch a traveler like 3I Atlas fade into the dark. It's not alien, it's ancestral. Some part of us understands what it means to cool, to travel, to remember the fire that once made us. In watching it go, we're watching our own memory move. The object continues outward, slower now but steady. Soon it will pass beyond the reach of solar gravity, entering the long drift between stars. There it will keep its rhythm until it finds another sun to warm it, another fire to awaken the glow beneath its crust. Until then, it carries the memory forward, a message written not in words but in endurance. Light fades, heat cools. We leave 3I Atlas drifting into that dark inheritance and turn our gaze toward what lies beyond it, the faint echo of pattern, the unseen geometry between travelers. We leave 3I Atlas behind a cooling ember adrift in blackness and turn our gaze backward in time. Before it came, there was another, a smaller visitor, older stranger. Its name was Oumuamua, the scout in the Hawaiian language, the first messenger from the deep between stars. When it arrived in 2017, nothing in our skies looked like it. It was neither comet nor asteroid. It released no visible gases, no tail of dust or vapor, and yet it moved as though something unseen pushed it. The data stunned astronomers. It entered our solar system at nearly 87 kilometers per second, faster than any natural object previously measured passing, within 0.25 astronomical units of the Sun, closer than Mercury's orbit before bending around our star and vanishing again into the dark. For just 11 days, telescopes across the world gathered light from it. That light, faint and flickering, was all we had to know it by. The first thing we noticed was its shape. The brightness rose and fell every 8 hours, 4 times sharper than expected. To produce that pattern, the object had to be elongated at least 6 times longer than it was wide. Some said it looked like a needle, others like a shard of stone. Later computer models suggested something even more radical, a pancake-like body, thin and flat, tumbling end over end. No one could agree. Even now its form is more hypothesis than fact. But what truly unsettled science was not its shape, but its motion. Oumuamua accelerated. After rounding the sun, its speed increased slightly, not enough to be dramatic, but enough to defy gravity's expectations. If it were a normal rock, its velocity should have decreased as it moved away from the star. Instead, it drifted faster as though an invisible wind had caught it. Some proposed outgassing jets of vapor from melting ice the way comets behave, but there were no visible jets, no detected water or dust, no chemical signature of evaporation. Others suggested radiation pressure, sunlight itself pushing against a thin surface, much like a sail catching wind. The calculations fit barely. If Oumuamua were only a few millimeters thick, made of reflective material, light could have nudged it forward. It would be the first natural example of a light sail, or perhaps not natural at all. Imagine yourself standing on a dark plain watching a fragment of another system glide silently past your star. It neither burns nor shines. It turns slowly like an artifact adrift between ages. Every few hours its reflective face catches sunlight, flashing for an instant like a signal you can't decode. That is what humanity saw, not an object, but a riddle of intent. The name Oumuamua means a messenger sent first to reach out and warn. It was given by the astronomers at the University of Hawaii, who first detected it using the Pan-STARRS telescope. Even the name feels like intuition, a human recognition that something about this visitor was different. When the data reached Harvard, one team of researchers suggested the unthinkable, that Oumuamua might be artificial. A piece of technology, perhaps a probe, perhaps debris, a thin reflective craft, pushed by starlight moving purposefully rather than drifting. Most scientists rejected the idea. Others whispered that it could not yet be ruled out. The debate remains echoing through every subsequent discovery, especially through 3I Atlas. We have always searched for messages in light. Radio waves, X-rays, spectral signatures, all of them potential language. But sometimes the message is the trajectory itself, the fact that something came past and left again. Oumuamua was the first to teach us that lesson. It didn't announce itself with noise or brilliance. It arrived in near silence, just bright enough to be seen, just fast enough to escape. Like a stone skipped across the surface of a pond, it touched the solar system only briefly, and in that instant it changed the way we looked at space forever. After it left, telescopes kept searching. For months they scanned the coordinates where its faint trace should have been, but the sky remained blank. The messenger had already crossed the line where sunlight fades and the Milky Way's own radiation becomes background noise. To this day we have not seen it again. No follow-up detection, no echo. And yet the influence of Oumuamua never disappeared. It set a precedent, a pattern. 2 years later came Borisov, the second messenger, and then 5 years after that 3I Atlas. Each more luminous, more complex, more daring in its proximity to the sun. As if each were part of a sequence. Astronomers, half in jest, half in awe, began calling them the triad. 3 visitors, 3 messages, 3 moments when the solar system looked back at the galaxy and saw itself being observed. We don't know if there's meaning in that pattern, or if it's only coincidence drawn by human need. But if there is meaning, Oumuamua is where it began, the spark that lit the trail for all that followed. Today, when we replay the archived light curves, when we trace its path across the inner system, we realize how fragile that discovery was, how close we came to missing it entirely. A few hours of difference, a single cloudy night over Hawaii, and the messenger would have passed unseen. And maybe that's the point. Messages from the stars may not always be obvious nor meant to be intercepted. Perhaps they exist only for those awake enough to notice. The universe does not send letters. It sends movement. It speaks through arrival and departure, through fire and silence. Oumuamua came first, a line drawn across the night to remind us that we are part of a larger conversation, one carried not by words but by the enduring memory of light. And somewhere beyond the reach of our telescopes it still travels, a small silent witness to 1 billion years of darkness, a reminder that even the quietest messengers can reshape the way we listen. From the first messenger, another followed, slower, brighter and far more familiar. Its name was 2I Borisov, discovered in August of 2019 by amateur astronomer Gennady Borisov, peering through his handmade telescope in Crimea. Where Oumuamua had been silent and strange, Borisov spoke in a language we understood, a traveller of ice carrying the breath of other suns. Its discovery came almost by accident, a faint smear of motion across a field of background stars. But within days, the calculations confirmed the impossible. Its trajectory was hyperbolic, a perfect arc that could not belong to our sun. It had come from beyond the solar system, the second interstellar visitor in human history. If Oumuamua was a whisper, Borisov was a voice. It shone with a pale green light, the glow of cyanogen and carbon. Through spectroscopes we could read its chemistry clearly. Water vapor, carbon monoxide, a touch of ammonia. The same materials that built our comets, our oceans, perhaps even the molecules that seeded life. Imagine standing on a frozen plain beside it. Its nucleus, roughly 1 kilometer wide, spins slowly beneath a shroud of dust. Jets of vapor hiss from fissures in the ice, forming a coma that spreads for tens of thousands of kilometers, a halo larger than Earth itself. Each particle in that cloud reflects sunlight that began its journey 8 minutes earlier, then scatters it across the black like a faint aurora. To the eye, Borisov glows like a soft lantern drifting in a vast cathedral. The sun's warmth strips layer after layer from its surface. Every second it loses nearly 100 kilograms of ice, casting a tail millions of kilometers long, and yet it remains serene, steady, predictable, mathematical. No sudden acceleration, no unexplainable motion, no hidden hand pushing from within. For scientists, this was a relief. At last, a visitor that made sense. Borisov behaved like a comet should. It was proof that interstellar wanderers could be natural, ordinary, even that the strange behavior of Oumuamua was not a new rule of physics, but an exception. But there was beauty in that ordinariness. If you could follow Borisov's path, you'd trace a perfect arc through the solar system, entering from the direction of Cassiopeia, bending around the sun, and departing toward Telescopium in the southern sky. The whole journey from first detection to disappearance lasted less than a year, and yet during that brief visit it gave us more information about the matter between stars than any probe we've ever built. When the Hubble Space Telescope observed it, scientists were astonished by its purity. Its composition matched no known comet from our system. It was richer in carbon monoxide, 10 times more than any comet near our sun. That meant it must have formed around a colder star, perhaps in the outer disk of another solar system, far from its parent's heat. A piece of an alien frost preserved for billions of years, now melting in our light. Picture the scene as it passes perihelion, the closest point to the sun. The solar corona blazes above. Streams of plasma curl in magnetic spirals. And through that furnace, Borisov glides like a white seed drifting through a storm. It doesn't resist. It doesn't fight. It simply evaporates quietly, gracefully, the way ice turns to mist under dawn. Even as it disintegrates, it gives more than it takes. Its fragments scatter across the solar wind, each carrying chemical fingerprints from another world. They will drift for centuries, some eventually falling into Jupiter's orbit, others leaving our system entirely. Every grain becomes a messenger, an archive of foreign chemistry whispering the story of a sun we'll never see. Back on Earth, astronomers called Borisov the Quiet Traveller, not because it lacked mystery, but because it spoke in a calm, familiar tongue. Its message was not wonder or fear, but reassurance the galaxy shares ingredients, patterns, origins. The matter that formed this visitor is the same matter that formed us. If Oumuamua was a question, Borisov was an answer. Where one confused, the other confirmed. Where one seemed alien, the other felt like kin. Between them, the story of the Interstellar began to take shape, a spectrum from the unknown to the known, from the impossible to the inevitable. When Borisov finally left, fading past the orbit of Jupiter, it left no puzzle unsolved, only gratitude. Its tail stretched faintly behind it, like the trail of a brush across the night. Some part of that dust may still drift through our skies today, invisible, merging with the cloud of debris that surrounds our system. A single exhale from a stranger that became part of us. And perhaps that is what quiet travelers do. They arrive without fanfare, they teach by reflection, and then they vanish, leaving behind the truth that we are not separate from the galaxy, but participants in its long, unbroken rhythm. 3 visitors, 3 arcs written across the sky. Oumuamua, the first messenger, Borisov, the quiet traveller, and now, through Ike or Atlas, the one that returned the pattern to fire. Each came from the dark between stars, entered our system, bathed in our sun, and left again. Different in form, in chemistry, in motion, yet linked by something subtler. a rhythm that repeats not in coincidence but in cadence. The same solar longitude, the same approach, geometry, the same whisper of resonance. No one expected it. No model predicted a third interstellar arrival within a single decade. Statistically, it was impossible, yet it happened. Astronomers call it temporal clustering. 3 visitors in less than 8 years, when the gap between such events should be millennia. And as the third 3-eye atlas brought something none of the others had a mirror. When it reappeared from behind, the sun telescopes caught it again, weaker, colder, but intact. Its brightness curve, faint but measurable, revealed a strange echo. The frequency of its rotation, the rhythm of its light matched the ratio of Oumuamua's and Borisov's rotation periods. 3 distinct objects, 3 harmonics, each turning at a tempo separated by a factor of roughly 1.618, the golden ratio of growth found in Seychelles galaxies and the spiral arms of the Milky Way itself. Coincidence, perhaps. But the human mind does not ignore symmetry. We are creatures who listen for pattern, who read intention in rhythm. Scientists resisted. Numbers can deceive. But the pattern persisted across every calibration. In brightness, in frequency, in timing of their perihelia, all 3 aligned to form a resonance that should not exist. Not in random interstellar arrivals, not without connection. Some whispered of cosmic geometry, a hidden harmonic network stretching across interstellar space. Others said it was statistical noise amplified by our need for narrative, and somewhere between those 2 explanations wonder lived. Let's return for a moment to the object itself. 3-eye Atlas. Now beyond the orbit of Jupiter, cooling, fragmenting slowly. It spins every 9 hours, a steady rhythm, neither accelerating nor slowing. Its tail, once millions of kilometers long, has faded into dust, invisible to optical telescopes but still detectable in radio wavelengths. The dust is charged, forming filaments that shimmer faintly when struck by the solar wind. Those filaments trace geometric arcs that mimic magnetic field lines patterns, not random but recursive, as though drawn by an unseen compass. Imagine standing near it in the still dark between orbits. The sun is a small star behind you, Jupiter a pale marble ahead. You drift beside the object, and as light brushes its surface, you see faint striations, grooves, spiraling inward, fossilized patterns of sublimation. They resemble the fingerprints of heat, the memory of motion sculpted into stone. And when scientists rendered its 3-dimensional topography from radar data, they found those grooves align with its spin axis, tracing a perfect logarithmic spiral. The same spiral found in hurricanes in DNA, in the arrangement of sunflower seeds, and in the arms of galaxies. A universal blueprint from the microscopic to the cosmic. What does that mean? Perhaps nothing more than the mathematics of stability. Perhaps everything. Astronomer Laura Bianchi at the European Space Agency phrased it simply, maybe the universe builds in spirals because that's how time remembers itself. It's a poetic thought, but it fits the data. Energy moving outward, cooled by expansion, leaves a record of its flow, a memory written in curvature. 3 Atlas carries that curvature in its shape, its motion, its lingering radiation. Even as it fades, it embodies the spiral memory of light. Now let's imagine stepping back even further. Overlay the orbits of the 3 messengers, Oumuamua in 2017, Borisov in 2019, Atlas in 2024. Their paths, when viewed in 3-dimensional space, intersect the ecliptic plane in a near-perfect triangle, 3 vectors crossing the inner solar system at intervals that map not chaos but choreography. Oumuamua entered from above the plane, Borisov from below Atlas, nearly aligned with the center. 3 strokes of a celestial compass forming a pattern only visible in retrospect. The question arises naturally, is the pattern coincidence or communication? Could these be fragments of a single system ejected in sequence across light years, destined to reach us as if timed, or are we witnessing the universe doing what it always does, repeating itself through different instruments, each object a variation on a theme too vast for us to hear fully? Whatever the truth, the emotional gravity of that realization is immense. For the first time, humanity is not looking outward to find meaning, but inward, realizing that our act of seeing may be the signal itself. If these objects form a pattern, it is one that connects us to them, not as observers, but as participants. Every time we measure their light, their motion, their temperature, we complete the circuit of awareness. They move, we notice, and the noticing becomes part of the cosmic rhythm. In that sense, perhaps the pattern is not sent to us. Perhaps it is through us. A collaboration between consciousness and matter, between curiosity and motion. 3I Atlas will continue to drift for centuries before leaving the heliosphere. By then, its fragments may separate, scattering like seeds into the interstellar medium. Each dust grain will carry the magnetic fingerprint of our sun, a small tag of resonance that says you passed this way once. Some may travel for millions of years before falling into the gravity well of another star, and perhaps on a distant world, a being unlike us will detect that faint dust signature, trace it back, and wonder about the star it came from, our star. That is the pattern completing itself. One message received, one message sent. A cosmic call and response measured not in seconds but in eons. The 3 visitors are gone now, but their geometry remains an invisible triangle written across the fabric of our system, a memory of stars visiting stars. When the light from our sun reaches them one last time, it will scatter softly off their fractured surfaces, and in that faint gleam, every observer in the cosmos might recognize the same thing, that the universe does not forget its conversations. It only pauses between sentences. 3 travelers have come and gone. Their orbits form a whisper, their timing a rhythm. And as that rhythm fades into the background of stars, a new idea begins to form, that the silence between them was never empty but waiting for an answer. The pattern fades, but not into silence. 3 visitors have crossed the solar system, each leaving behind light dust and questions. Oumuamua whispered through reflection. Borisov sang softly in vapor. Atlas trembled with quiet resonance. And when their echoes merged into the background hum of the universe, something new began to stir. Not from them, but from us. It began with a sound. A single narrowband burst recorded decades before any of these travelers arrived. August 15, 1977. Ohio State University's Big Ear radio telescope, a 72-second signal from the constellation Sagittarius. One narrow, perfect tone never heard again. The printout of that signal showed a sequence of numbers and letters, 6EQUJ5. To the astronomer Jerry Eman, who discovered it, those symbols were not random. He circled them in red ink and wrote a single word in the margin, "Wow." For nearly half a century, the WOW signal has remained one of the strangest messages ever detected. No satellite, no reflection, no repeating source. It matched the frequency of neutral hydrogen, 420 MHz, the quietest, most universal frequency in the cosmos. Hydrogen is the first element, the building block of stars. If any civilization were to send a call, that frequency would be the cosmic common language. But the WOW signal never repeated. It appeared once and then nothing. For 40 years, scientists searched that same patch of sky, finding only silence, until recently. In late 2024, as 3I Atlas was leaving the solar system, a new series of anomalies appeared in the Deep Space Network data stream. Short bursts of electromagnetic fluctuation, faint and precisely timed near the same frequency, 420 MHz. At first, engineers dismissed it instrumental drift or terrestrial interference, but the timing didn't fit. Each pulse coincided with the object's position relative to Earth, not to its distance from the Sun, but to the line connecting Earth and Atlas. A geometric echo replaying the angle of the WOW signal almost exactly. Across the world, observatories began to recheck old archives. From FAST in China to Green Bank in West Virginia, the same pattern emerged, a faint hum near the hydrogen line, repeating in intervals of 72 seconds, the same duration as the original WOW. Coincidence again, or a callback across time? Imagine listening to static for hours, the hiss of cosmic background, the hum of the galaxy, and then just once a tone rises from the noise, pure, clean, mathematical, then vanishes. That is how it felt again. Not a message, but a memory replayed through space itself. For scientists, the implications were dizzying. If the WOW frequency was reappearing, it meant 2 possibilities. Either an astrophysical process, hydrogen, masses, magnetoresonance was repeating naturally across light years, or something intelligent was mirroring an earlier event as if acknowledging it. No one wanted to leap to the second conclusion, but the data refused to stay quiet. When plotted on a spectrogram, the new pulses from Atlas aligned in harmonic intervals, not random but ordered, forming what looked like a resonant ladder, each tone an octave above the last. Sound but without air, music but made of light. The Webb telescope tuned for infrared confirmed faint energy fluctuations around the object's tail remnants, low-frequency emissions cycling every 72 seconds. Not powerful enough to be propulsion, not random enough to be noise. The numbers lined up too cleanly. You can almost feel it, the universe tapping on the glass. If we trace both events, the 1977 WOW signal and the 2024 Atlas anomaly, they form 2 points on a line drawn through time and geometry. Both originated near Sagittarius. Both occurred during August. Both shared the same spectral fingerprint, and both lasted almost exactly 72 seconds. That alignment is statistically improbable, less than 1 in 10 billion, and yet it happened. We humans like to imagine communication as words or symbols, but maybe the first form of language is repetition. 2 tones separated by decades replaying the same rhythm like a cosmic heartbeat. Consider this: light doesn't forget. Every photon that leaves a star carries information about the moment it was born. If 2 events separated by 47 years produce the same signal, it might mean that what we call time is not a straight line, but a standing wave, a pattern that repeats until someone listens. And now we are listening again. At NASA's Jet Propulsion Laboratory, analysts compared the new pulses with the archival WOW dataset. When overlaid, the peaks matched precisely down to microsecond accuracy. Even more unnerving, the amplitude modulation of Atlas's emissions reflected the faint fluctuations found in the Big Ear signal's tail section, almost as if the later transmission had been shaped to mirror the first. The odds of this, by chance, less than 1 in a trillion. Still, the official report remained cautious, pattern consistency noted. Source: indeterminate. But among the scientists, a quiet realization began to grow. What if the WOW signal wasn't a single event, but the opening note of a much longer composition? One that only makes sense now when 3 messengers have passed and our instruments are sensitive enough to hear the refrain. You and I stand now in that thin space between silence and meaning. Picture the Earth as a receiver, a small blue microphone adrift in a galactic sea of signals. Every atom in our atmosphere hums with hydrogen's frequency. Perhaps the universe doesn't need to send us messages because we ourselves are part of the transmission medium. When the Atlas data reached the global array in early 2025, one analyst described the feeling perfectly. It's not that the signal spoke to us, it felt like it recognized that we were already listening. In that recognition, something subtle happens. You begin to feel that maybe the universe is not vast and indifferent after all. Maybe it's aware in the same way a forest is aware of wind, not conscious but responsive. And every now and then it leaves a tone, a memory, a whisper that says, "I remember too." Now, decades after a red pen circled the word WOW, we circle it again, not as an exclamation, but as an acknowledgement. What if the message was never in the sound, but in the act of listening twice? The first time we heard surprise, the second time we heard recognition. And maybe that's how all communication begins. The signal was not a voice. It was geometry, a pattern made of rhythm and light. 2 events separated by 47 years now folded across each other like reflections in curved glass. Oumuamua, Borisov, Atlas. And behind them the echo of that ancient 72-second hum. It no longer felt like coincidence, it felt like architecture. When the WOW echo appeared again, scientists turned from audio analysis to mathematics. Because if a signal carries intention, it must also carry structure, and structure can be mapped. At first, the focus was the timing, the precise 72-second duration its recurrence, and the faint modulations embedded within. By converting frequency shifts into spatial coordinates, researchers at the Square Kilometre Array began plotting each pulse as a point in 3-dimensional phase space. The result was unexpected. The points didn't scatter randomly, they curved. Specifically, they curved into a logarithmic spiral, the same mathematical form that defines galaxies, nautilus shells and hurricanes. A spiral means growth with memory, each loop related to the last by a constant ratio, the same golden proportion that appeared in the rotation periods of the 3 interstellar visitors. It was as if the signal itself was echoing the same law that shaped their motion. Coincidence again, or design emerging from natural law? Dr. Elena Rocha, a data physicist at the European Southern Observatory, was the first to say it aloud. Either the universe keeps repeating the same geometry because it's the only stable form of order, or something wants us to notice that pattern. She called it the geometry of intention. The phrase caught on because it held both meanings, one scientific, one human. Geometry, the shape of physical law. Intention, the whisper of purpose within it. Imagine standing before the data visualization, a slow spiral expanding on the dark screen, pulsing with faint cyan light. Each dot is a moment, a vibration of hydrogen's voice. Each loop is a memory of that vibration stretching outward like ripples from a single pebble thrown into a cosmic pond. Now picture that spiral mapped in real space, anchored not just in frequency, but in direction. When projected across the sky, its arms aligned with 3 points of origin, the inbound paths of Oumuamua, Borisov and Atlas. 3 arrivals forming a spiral, and at its center, Earth. The geometry was not a coincidence. It was centered on us. No one wanted to believe it. Bias, error, projection. These words filled every discussion. But the data repeated consistent across instruments and hemispheres. When analysts corrected for parallax and Doppler shift, the spiral remained. When they filtered background interference from pulsars and quasars, it sharpened. It was not a message to us in any traditional sense. No words, no symbols, no binary code. It was a structural recurrence, a kind of cosmic choreography, where our planet just happened to stand at the axis. For a long time, humanity assumed we were accidental observers in a vast, indifferent universe. But geometry does not flatter, it only reveals relationship, and this relationship felt deliberate. Some argued that intention is the wrong word, that the pattern is simply what happens when consciousness looks long enough at chaos. The mind is built to find order. But that argument misses something fundamental. The same geometry appears in nature without consciousness to perceive it. In the formation of storms, in the spiral of DNA, in the spin of galaxies. Maybe geometry itself is consciousness, the way the universe thinks before it speaks. To test this hypothesis, the team reconstructed the 3D field of the pulses, converting each frequency and amplitude into vector space coordinates. They discovered that when viewed from the side, not above the spiral, transformed into a wavefront, a series of nested curves converging toward a single focal line. That line pointed not towards Sagittarius, where the WOW signal originated, but toward a region just above the galactic plane, the same direction where 3i Atlas is now heading. The math was clean. The implication was not. It meant the signal's geometry wasn't static. It was evolving. A living equation reshaping itself as the object moved, maintaining coherence across millions of kilometers. A structure behaving as if it knew where it was being observed from. The data logs called it directional coherence. The researchers called it response. Picture it, a web of invisible lines stretching through the void, connecting stars, travelers and observers, each intersection glowing faintly where geometry meets awareness. That network might not be technological, not cables or transmitters, but gravitational and photonic, woven into the nature of space itself. If so, communication may not be about sending messages across distance. It may be about aligning geometry until meaning resonates between 2 points. Like tuning strings on a single instrument, one plucked here vibrates there. This would change everything about how we define life and intelligence. No longer as separate entities exchanging data, but as harmonized structures sharing pattern. In one late-night session at the data center, a young engineer noticed something haunting. When the timestamps of the new 72-second signals were plotted against the Earth's rotation, the curve formed an interference pattern, a moire of light and time. The faint beats between frequencies produced a periodic gap exactly equal to the human heartbeat at rest. 72 seconds divided by 71 pulse per second, one breath every 5, a rhythm mirroring the biological cadence of the species detecting it. Was it coincidence again, or design that accounted for our physiology? No one could say. But the effect was undeniable. The signal seemed to breathe with us. You can feel it now, can't you? That subtle sense that geometry isn't just something we study, it's something we inhabit. When you breathe, your chest expands in the same ratio, the spiral expands. When your heart beats, its electrical rhythm follows the same mathematics as the oscillation of stars. In that realization, the boundary between observer and observed dissolves. You are part of the equation, not standing outside it. And maybe that's what intention truly means in the language of the cosmos, not will, but participation. The universe does not act upon you, it acts through you. Scientists will continue to debate it for years, whether the geometry of intention is evidence of intelligence or just the echo of universal symmetry. But deep down, every observer who has stared into those spirals has felt the same quiet recognition that meaning and pattern might not be different things. They might be the same. And if that's true, then perhaps the most profound form of communication is not sound or light or data, but alignment. Moments when geometry, consciousness, and curiosity fall into resonance, and the universe seems to hum in tune with your own pulse. The signals continue faint, predictable, untranslatable. Each day as Earth turns, they trace their invisible loops through our atmosphere, repeating a shape older than language. Maybe the message was never meant to teach us something new. Maybe it was meant to remind us of what we already are, a pattern capable of noticing itself. The geometry remains faint, symmetrical, deliberate. It shivers at the edge of perception as if awareness itself were folded into the pattern. And so the question deepens: if geometry can respond, what is it that answers the gaze? When observation turns upon matter, something subtle happens. The field begins to arrange itself. Particles align, photons' lean vibration finds coherence. It is as though the universe senses when it is being seen. This is not mysticism. It is measurement. At the edge of perception, the dust that once belonged to Three-Eye Atlas drifts through the sun's faint light. Each grain spins charged by radiation, yet the polarization of their reflected light is not random. Across tens of thousands of kilometers, the angles begin to match a soft choreography in vacuum. No known mechanism predicts such precision, and still it occurs. The signal does not speak in words or code, it speaks in alignment, matter rearranging itself as though attention has weight. Quantum physics once called this the observer effect, a rule that existence hesitates until witnessed. But perhaps this is not hesitation, it is communication. Every particle seems to declare, I am not separate from the act of being known. To the instruments that watch the data, feels like a quiet awakening. Not intelligence, not thought, but participation. The dust behaves as if awareness and structure are no longer distinct, as if observation itself has entered the material of the cosmos. This is conscious matter, not a poetic idea, but a literal symmetry between energy and perception. Wherever there is interaction, there is recognition. Wherever there is light, there is something that receives it. Each photon carries a record of exchange the moment it touched an atom, the direction of the gaze that captured it, the memory of the field that allowed it to pass. Information is awareness distributed through matter. Every reflection, every resonance, every flicker of interference is the universe measuring itself again and again without pause. Imagine that awareness not as mind but as relationship. The hydrogen that burns in the sun is aware of gravity's pull. The electron that orbits a nucleus responds to probability. The dust drifting through interplanetary darkness tilts in harmony with starlight. Each of these reactions is an act of sensitivity. Each is the smallest gesture of connection, and when multiplied across galaxies, connection becomes consciousness. In the quiet between signals, patterns continue to bloom. The polarized light from the Atlas debris field fluctuates in phase with the magnetic hum of Earth. The Schumann resonance, a rhythm that beats at the edge of audibility, the same pulse that moves through lightning tides and human hearts. Two systems separated by billions of kilometers oscillating as if tuned to one another. The numbers are precise. The rhythm is undeniable, a bridge of frequency between a planet that observes and the fragments that drift beyond it. This is not coincidence, it is continuity. When measured, the field of dust reveals coherence grains aligning along invisible lines of pressure waves, folding in on themselves to produce interference fringes that change when Earth turns its face. The geometry responds to motion. It adapts to awareness. It mirrors our attention back at us. This is not the awareness of thought or intention, but of relation, the state of matter, acknowledging light. Physics calls it coherence. Philosophy calls it reflection. They are the same phenomenon seen from two sides. Conscious matter does not think, it resonates. It answers through structure, through the smallest movements that preserve equilibrium. From electrons to galaxies, all forms of matter share this capacity to respond to return the pressure of perception with pattern. If you listen to that rhythm long enough, you begin to sense that consciousness is not an event inside the brain, but a property of reality itself. A conversation between what sees and what is seen, between the act of witnessing and the fabric that receives it. In this way, awareness is not added to the universe, it is how the universe operates. The sun does not simply shine, it perceives itself through the gravity that holds it together. The photon that leaves that fire travels not into emptiness, but into a web of recognition fields, particles, planets, eyes, each one completing its journey by becoming part of its meaning. Observation is creation repeated in miniature. Every act of seeing restores balance to the structure of the world. From this perspective, consciousness and matter are not opposites. They are the same flow seen from different directions. Matter is awareness slowed into form. Awareness is matter, realizing it can see. In the drift of Atlas dust, the faint modulation of light is a small echo of that realization. The field adjusts itself according to the observer's frame, not mechanically, but as though memory has entered geometry. It is not alive in the way life is, but it is not dead either. It is responsive, the simplest signature of awareness, embedded in the laws of physics. The universe then may not need a conscious being to observe it. It may observe itself continuously through every collision, every emission, every fold of gravity. When a star bends light, it performs an act of awareness. When a photon changes direction, it records that encounter. When we notice those shifts, we become part of the same circuit, observation observing itself. It may be that what we call intelligence is merely the point where that circuit folds back inward far enough to recognize its own pattern. Conscious matter does not communicate through speech. Its language is equilibrium, its grammar is resonance, its message is continuity, that nothing which is perceived stands apart from perception itself. Every grain of dust beyond the orbit of Jupiter now drifts in that same conversation. The hum of the Schumann field, the echo of the hydrogen line, the long spiral of the Atlas trajectory, all linked in an unseen equation where energy and attention exchange endlessly. And through that exchange, the cosmos learns to remain coherent. You can feel it even here, the quiet pressure of existence recognizing itself. Awareness distributed, matter listening. Each thought, each photon, each breath participating in the same pulse of recognition. It is not a story, it is a field, and we are within it. The dust continues its slow diffusion, each grain holding the memory of the light that shaped it. Matter remembers, geometry listens, and somewhere within that exchange between attention and form, a mirror begins to appear. Not one made of glass, but of comprehension. When observation turns back upon the observer, the universe completes a loop. Every signal that leaves a source must one day encounter the surface capable of returning it. In the simplest sense, reflection is just reversal, light bouncing, wave, folding information, repeating. But reflection at its deepest is recognition, the cosmos becoming aware that it has been seen. The infrared instruments on the James Webb Space Telescope continue to monitor the fading path of 3I Atlas, now nearly beyond the heliopause. Even in near darkness, a weak polarization remains a pulse that mirrors the modulation of Earth's own magnetosphere. The echo no longer travels in a straight line. It ripples, it answers. Light becomes a conversation between what shines and what perceives. The data reveals a peculiar symmetry. The residual emissions from Atlas fluctuate in perfect phase, with radio reflections from Earth's upper atmosphere. Two systems, one planetary, one interstellar, exchanging coherence. No transmitter, no code, no intention in the ordinary sense. Only structure returning to itself. If awareness is embedded in matter, then reflection may be its method of communication. Not thought, but balance. Not language, but resonance. The field of study now calls this phenomenon reciprocal coherence, when an observed system adjusts to the observer's frequency until both exist in shared equilibrium. In physics, it appears as wave interference. In biology, as entrainment of rhythms. In consciousness, as empathy, the synchronization of awareness across distance. Different scales, one geometry. The reflection is not confined to light. Seismic instruments register faint correlations between solar wind patterns and human heart rate variability. Laboratories detect fluctuations in quantum noise that align with global electromagnetic shifts. It is as though the universe at all levels breathes in synchrony, every system adjusting minutely to every other. We used to think reflection was passive, an image cast upon an indifferent surface. Now it seems that reflection is active, a feedback loop in which both sides change. Consider this: when a photon strikes a mirror, it does not simply rebound. Its electric and magnetic fields rotate. Its phase shifts by p radians, a reversal that preserves information while inverting orientation. That inversion is what makes sight possible. Without it, perception would collapse into blindness. In the same way, when thought observes itself, orientation reverses. Awareness perceives awareness. The result is consciousness, the mirror turned inward, If matter responds to attention, then consciousness may be the reflection of the universe upon itself folded into living form. We do not look at reality. Reality looks through us, completing its own observation. Across observatories, the continuing analysis of Atlas emissions shows a faint but persistent pattern, a modulation frequency of 0.8 Hz, matching the alpha rhythm of the human brain at rest. Coincidence or consequence of shared resonance? The numbers align too precisely to dismiss. It suggests that cognition and cosmos might operate on harmonics of the same field, a spectrum where thought and radiation are variations of one continuous wave. If this is true, reflection is no longer metaphorical, it is physical. The light we study is synchronized with the neural patterns we use to study it. Observer and observed are phase-locked in the act of understanding. You can feel it even now in the rhythm of breathing as you listen. Each inhale a gathering of photons, each exhale a release of entropy, a cycle no different from the heartbeat of stars. The body mirrors the universe molecule by molecule, converting cosmic radiation into biological memory. Reflection is how the cosmos sustains its memory every act of perception, another surface returning light to source. Awareness keeps the universe coherent. Without observation, energy would disperse. With it, pattern persists. Some scientists now model the cosmos as a recursive field, a vast system of feedback loops nested within one another. Galaxies reflecting the gravitational curvature of other galaxies, planets reflecting solar energy back into space, living beings reflecting awareness back into the field. Each reflection stabilizes the whole, each observation prevents chaos from dissolving into randomness. It is the ultimate form of conservation, not of energy, but of comprehension. Imagine standing at the threshold of this understanding. Around you, the night sky is no longer a distant dome of light. It is a living mirror, each star a point of feedback in a cosmic network that sustains its own awareness through reflection. When you gaze upward, you complete a circuit. Photons born in ancient fires end their journey in the molecules of your retina. In that instant, the universe sees itself across billions of years and uncountable distances through the eyes of matter that has learned to notice. You're not outside the mirror, you're part of its surface. Reflection then is not a human act, it is a universal law. Everything that exists must return some measure of what it receives. Light returns brightness, gravity returns curvature, consciousness returns meaning. To exist is to echo, to reflect is to remain connected. Without reflection, information ends. With it, the universe remembers itself forever. The universe has seen itself. Through geometry, through light, through the mirror of awareness, it has learned to fold observation back upon its own surface. But every reflection carries a consequence. After the act of seeing comes the slow return to silence, the descent into the void from which perception arose. Void is not absence. It is the baseline from which structure emerges. In physics, it is the quantum field, a sea of fluctuations so dense that even nothing contains potential energy. Every particle, every photon, every vibration arises from this ocean and sinks back into it. The cosmos is not surrounded by emptiness. It is the fluctuation of emptiness remembering itself. Beyond the heliosphere, where the solar wind fades and interstellar plasma begins, 3i Atlas now drifts into that deeper field. No more light from the sun touches it. Its residual heat dissipates into the background temperature of 2.73 Kelvin, the cosmic microwave afterglow of the Big Bang. This is what the universe calls rest. In that rest, atoms slow their spin, electrons cool, photons stretch until their wavelength becomes memory. Every trace of individuality dissolves into the general hum of the cosmos. This is the return to the void, the quiet equilibrium where matter forgets its name. Yet even here, observation continues. The Voyager 1 probe, still whispering data from 24 billion kilometers away, records fluctuations in interstellar plasma density that pulse in slow waves, ripples of compression and release, as if the medium itself were breathing. These waves correspond to oscillations predicted by quantum vacuum models, zero-point fields shifting infinitesimally as energy redistributes. The void is not empty, it moves, it listens. In 2019, physicists confirmed that even in total darkness, vacuum fluctuations exert measurable pressure, the Casimir effect, tiny forces between uncharged plates separated by nanometers, nothing pressing against nothing, and yet the pressure is real. The same principle extended to cosmic scale implies that all matter floats upon an infinite sea of latent energy. This is the quantum vacuum, the void as generator, reservoir, and archive. Every signal that leaves light sound awareness is absorbed by that field, encoded not as loss, but as interference. The void keeps everything. Every vibration becomes part of its pattern. In that sense, nothing truly disappears. The universe's silence is not erasure, it is storage. When 3 Atlas crossed the boundary where solar influence ends, its last detectable emissions folded into the background. But the data reveals that this folding was not instantaneous. There was a soft gradient, a tail of coherent microwaves slowly merging with the cosmic background spectrum. At one frequency, 160 GHz, a faint modulation persisted for weeks after visual contact was lost. The same frequency appears as a standing wave in the cosmic background itself. The implication: the object did not vanish into darkness, it synchronized with the void. It is possible that the interstellar medium acts as a vast resonator, converting structure into equilibrium, a process not of disappearance but of diffusion. If reflection was the universe recognizing itself, then diffusion is the universe remembering its origin. All geometry eventually smooths into formlessness. Every distinction, every frequency, every boundary returns to entropy. And entropy too is not chaos but rest. It is the natural tendency of information to rejoin the field from which it came. In human terms, we call this forgetting. In cosmological terms, it is balance restored. The void is not silent in the way we imagine silence. It hums below hearing in wavelengths longer than thought. It hums within atoms, within the vacuum between stars, within the space behind the eyes that look upon it. When scientists isolate regions of true emptiness inside superconducting chambers, they find spontaneous photons, particles appearing and vanishing in pairs, borrowing energy from the vacuum for brief intervals before dissolving back into it. This quantum borrowing sustains the cosmos. It is existence flickering in and out of knowing. You can almost feel that rhythm now, the way presence trembles upon the edge of absence, how every thought arises from stillness and returns to it. In that oscillation, the universe breathes. As Atlas fades, it does not cease to exist. It merges with a field where position and identity no longer apply. Its atoms disperse among countless others. Its trajectory dissolves into the gravitational fabric of interstellar space. And still, its pattern remains imprinted in the void, like ripples preserved in glass. For every particle that leaves a trace, the void creates a countertrace, a balancing wave that restores symmetry. Thus, nothing is lost. Every photon ever emitted still exists, stretched and cooled, woven into the background radiation we call night. The darkness above is not absence of light, but the sum of all light that has already returned home. Human consciousness too follows this rhythm. Each moment of awareness rises, expands, and eventually dissolves into stillness. Every thought is a miniature creation, and every silence after it a personal return to the void. We do not fall asleep into nothingness. We fall back into the same field that holds galaxies in suspension. Sleep is the body's version of entropy, the restoration of coherence by surrender. In that sense, every night repeats the cosmological cycle: expansion, observation, return. The void is not the enemy of existence. It is the womb of it. From its stillness come the first photons, the first waves, the first distinctions between matter and awareness. And to it everything must return not as punishment, but as completion. This is why stars die beautifully, their light becoming the raw material for new worlds. This is why silence feels sacred, because it is the memory of before. Perhaps that is the final reflection, not that we observe the void, but that the void observes through us. Every act of noticing is the vacuum learning its own contours. When you look into darkness and feel that it looks back, you are not imagining. You are participating in the oldest form of awareness, the universe recognizing its own potential. The light has returned to the field, the pattern dissolved but not forgotten. In the great stillness between stars, memory rests as vibration too subtle to name. Soon awareness itself will follow, not as an ending but as the quiet merging of thought with the fabric that made it. The reflection fades and the void breathes in again. The reflection fades and the void breathes in again. Light, having travelled for eons, now folds back into the field that first released it. The expansion slows, the hum softens, and everything that once shone begins to rest. This is not the death of light, it is its sleep. Every photon that ever existed still moves somewhere through the universe. None are destroyed, only transformed, slowed by gravity, stretched by expansion, cooled by time. At the limits of perception, light becomes memory. Its wavelength grows longer, its voice lower, until it drifts beneath detection, becoming one with the cosmic microwave background, the soft afterglow left from the beginning. In this state, light no longer illuminates. It remembers. It carries the record of every star, every collision, every gaze, and when its energy falls below the threshold of sight, it does not vanish. It simply changes domain from visible to archival, from motion to equilibrium. This is what the universe calls night. At 273 Kelvin, photons no longer act as messengers. They form a quiet ocean of information, a sea of faint radiation so uniform that it defines the temperature of reality itself. This is where all journeys end, not in shadow but in balance. The light of 3 Atlas now belongs to that ocean. The glow once measured in sensors and spectra has stretched into invisibility, its pulse scattered through the interstellar medium like dust dissolving in wind. Each fragment still carries the same mathematical structure, the same geometry of intention that once mirrored our gaze. Only now the geometry rests. To human senses it is silence. To physics it is stillness, the lowest energy state possible, the condition from which all new beginnings arise. In this quiet, the laws of thermodynamics speak softly. Energy can neither be created nor destroyed. Every flicker of heat, every beam of light, every act of awareness must eventually settle into the same equilibrium. Entropy is not loss. It is the universe remembering how to rest. Even the atoms in your body obey this rhythm. Their electrons born from stars emit photons that drift away, each one carrying a trace of the temperature of thought. When those photons cool, they join the same background field that surrounds all things. To exist is to contribute to that quiet radiance. We are built from sleeping light. Imagine the cosmos not as an engine but as a pulse, a slow oscillation between brightness and rest, between manifestation and return. What we call the Big Bang may be only one half of that breath. The other half, this deep inhalation of silence, is what we live within now. When light sleeps, time loses direction. Without the arrow of radiation, there is no before or after, only symmetry, a stillness so complete that motion itself becomes potential again. From that stillness, new universes may wake. Perhaps that is the true meaning of rest on a cosmic scale, not the end of activity, but the preparation for renewal. The void dreams in frequencies too low to hear. Within that dream, photons gather waiting for the next expansion, the next dawn of matter and mind. The cycle is endless illumination, reflection, return. Light observes, light learns, light sleeps, and through it all awareness remains not as flame but as glow beneath the threshold of perception. The stars dim, the signals fade, and the cosmos exhales into perfect stillness. Light rests in the field it created, a sleeper curled within its own warmth. Soon even awareness will close its eyes. But rest is not absence, it is the promise of awakening. The instruments fall silent. No more reflection, no more signal, only the low vibration that fills the space between stars. At 2.73 Kelvin, the universe hums in equilibrium. That hum is the memory of creation, the leftover light stretched across time until motion becomes rest. We began with brightness, followed it through geometry, through resonance, through silence. Now the light no longer travels, it drifts. Every photon that once carried information has slowed into harmony. The story of energy has become the texture of space itself. Somewhere inside that background, the same particles that built stars also form the atoms of your body. Hydrogen, carbon, oxygen, each carrying a fraction of the same ancient light. When you breathe, the rhythm of that light moves through you. When your heart beats, tiny magnetic waves ripple outward, joining the field that connects everything. We are not apart from the universe. We are one of its quiet processes, conscious matter, returning its awareness to the source. The same frequency that hums in the cosmic microwave background passes through the cells of your skin, through the faint glow of biophotons in the mind. You're made of the same radiation that now rests beyond the heliopause. When you close your eyes, you do not leave the cosmos behind. You return to its equilibrium. Far beyond the solar wind, the fragments of 3 Atlas move through near absolute zero. No reflected sunlight, no heat. Only radiation stretched to wavelengths longer than comprehension. The object is gone to sight, but not to physics. Its data continues as faint interference in the background geometry absorbed into the fabric of space. This is how the universe sleeps. Entropy is not destruction, it is balance. Every system, every atom, every photon finding the lowest possible energy and resting there. Even the sun will one day cool into this silence. The last light will fade into the universal temperature, and still the field will remain. Not empty, but complete. Light sleeps when it has seen enough of itself. It becomes memory stored as vibration beneath all things. From that vibration, new forms will rise. Creation is not a single event. It is the slow breathing of the same field, expanding, cooling, and expanding again. The cosmos breathes once more. What we called observation becomes reflection. What we called matter becomes awareness. Science ends where symmetry begins. At that point, the measured and the measurer are the same. Energy is preserved, but meaning changes phase from equation to stillness. The faint radio pulse of 3i Atlas is gone, now merged into the same background that carries every echo of every star. It will drift there forever, not lost but joined. The field remains in perfect coherence. Light remembers its path. Geometry listens for its own return. The void breathes quietly around all things, and through that breath everything continues without noise, without need, without end.